All right, welcome to another video of Chem with Com. Let's get going. So this is the second part of this topic, Lewis structures bonding in molecules. The specific topic is going to be Lewis structures and covalent bonds. Last time we did ionic bonds. Let's do covalent bonds this time. All right. So we left off and we saw that ionic compounds are held together by ionic bonds, which their plus or minus charges kind of come together because opposites attract. Ionic bonds are formed by atoms giving and taking electrons. Specifically, metals give up electrons, non-metals take electrons, and they usually come apart in water. Today, we're going to be covering molecular compounds. They're held together by covalent bonds. Covalent bonds are formed when atoms start sharing electrons. This is what keeps those atoms together. It occurs usually between, or it occurs between two nonmetals, and they usually don't come apart in water. All right. Okay. So again, come back to this slide and pause it, rewind it, whatever you need. It'll be there for you. All right. So covalent bonds are between molecular compounds. They're between two nonmetals. Remember, metals give up electrons, nonmetals share or take electrons. So if there's two nonmetals, they're not going to give up their electrons. The best they can do is share them. All right. So two nonmetals, they're going to share those electrons. All right. So this is an example of two chlorine atoms. Chlorine starts out like this, right? With, if you look on the periodic table, it's column 17. So they have 7 valence electrons. Another chlorine comes around or is around. Again, if there's one chlorine, there's a billion other chlorines, right? Trillions and billions and moles of them. And if you look here, this chlorine on the left and this chlorine on the right are going to share these pair of unpaired electrons, right? So it's going to look something like this, where it's going to be chlorine with those 8 electrons and another chlorine with the 8 electrons. And I'll circle what I'm talking about, all right? This chlorine on the left has 8 electrons. 7 of them came with the left chlorine. It borrowed one from the right chlorine. This chlorine on the right has 8 electrons. It started with 7, but it borrowed one from the left chlorine. So that way they both have 8 electrons. So octet rule satisfied. All right. That's why on Earth, you normally find chlorine as Cl2. It's a Cl2 gas. It floats around. That's how you normally find it on Earth. Let's do that with fluorine. Fluorine has 1, 2, 3, 4, 5, 6, 7 electrons. Another fluorine is around 1, 2, 3, 4, 5, 6, 7 electrons. They're going to share these two. That's going to be the bond that keeps those fluorines together. So it'll look like this. 8 on this side, 8 on this side. And it's happy. It's F2. You always find that on Earth as F2. Now, this isn't just an octet rule. This is a duet rule as well. Remember, hydrogen and helium can only hold 2 electrons because they only have one energy level, right? So hydrogen comes in with 1 electron. There's another hydrogen always around that has another electron. They're going to share their 2 electrons. It's going to look like this. Right? This hydrogen on the left has 2 electrons. This hydrogen on the right has 2 electrons. And it's just going to look like this, H2. That's how you find hydrogen on this planet, as H2. Now let's go back and take a look at helium. Helium has two electrons. It doesn't want to give, it doesn't want to take electrons, it doesn't want to give electrons, it doesn't want to share electrons. It just stays as helium, a single atom. This is what's called a diatomic atom. Two atoms of the same kind. This is diatomic. This is diatomic. This is a monoatomic atom because it's already happy. The reason why things form and molecules form is because they're not completely quote unquote happy, right? They don't have feelings, but they're not stable by themselves. So what happens is they give electrons, take electrons, share electrons until they're stable. That way they hang around for longer. And this is the most stable form of fluorine, or not the most, but one of the most stable forms of fluorine is diatomic. Same with chlorine, same with hydrogen, same with helium. Helium's a monoatomic, again, because it's already stable, right? It starts with two electrons. It wants two electrons. It already has what it wants, so it doesn't have to go out and change itself, right? All right. So now let's get to the meat of this, right? This is in the book, chapter 4.4, but it's very wordy. So I'm going to show you my way to do it. You don't have to do it my way, but you can pause it, take notes, take a picture, screenshot, put it into your notes, and use it the book's way. Or you can go to chapter 4.4 and they'll tell you how to do it there, right? But here, what I'm going to do is, yeah, show you my way. And then again, so this is the duet rule. Oh yeah, so let's go through this. So what we're going to do is we're going to count total valence electrons of all atoms together. Now, we're not doing core electrons because core electrons do not bond, right? Valence electron stuff on the outside, the electrons on the outside of the atom, that's the only thing the atom uses to interact with other atoms. It doesn't use core electrons. So count total valence electrons of all atoms. Negative charges mean we add electrons. Positive charges mean we subtract electrons. All right, we're going to draw the skeletal structure. Skeletal structure just means atoms only, right? Skeletal structure is atoms only. Symmetrical. If you have mirror image, yeah. So you can draw a line through it. Through it, and it's a mirror image. Another set of tips is hydrogen, fluorine, chlorine, bromine, and iodine are on the outside of the molecule. Okay, first thing you're going to do is you're going to place bonding electrons in pairs to connect the atoms. All right, you're just going to put two electrons. They always have to be in pairs. Electrons don't really like hanging out by themselves. They like to be in pairs. And you're going to put the rest of the electrons on the outside atoms, or I guess on the outside. I'll show you what I'm talking about. In pairs following the octet rule or duet rule for hydrogen and helium. All right. If an atom doesn't have all its electrons, share your neighbor's electron pairs. Okay, again, after you do all that and an atom doesn't have all its 8 electrons or 2 electrons if it's hydrogen and helium, you're going to share your neighbor's electron pairs. Other common things, but not always, is carbon is going to have 4 bonds, 0 lone pairs, and we'll tell you what lone pairs are in a little bit. Nitrogen has 3 bonds with 1 lone pair, and we'll just call them love electrons. Oxygen will have two bonds with two lone pairs. Halogens, which are fluorine, chlorine, bromine, iodine, they'll have one bond with three lone pairs of electrons. All right. It's a very complicated list, I know, but you can do it if you practice. So let's just start doing these to get some practice at them. All right. So let's bounce around a bit. Actually, yeah. Let's do this with just hydrogen. Let's just put a little line here. Will that work, hydrogen? Actually, no, let's do it with these. All right. So let's just do these. Count total valence electrons of all atoms. So we have a carbon and four chlorine. Remember that four means there are four chlorines. All right, so there are, if you look on your table of of valence electrons, carbon's going to have four because it's in column 14. Chlorine's going to have seven because it's in column 17. So you have 32 electrons total. All right. Draw the skeletal. So cool. We did this one. Draw the skeletal structure with these tips. It has to be symmetrical. Hydrogen, fluorine, chlorine, bromine, iodine are on the outside. Well, we have chlorine here. That should be on the outside. So let's draw it symmetrically with four chlorines on the outside. The only way I know how to do that is like this. Carbon in the center, chlorine on the outsides. All right. I'm going to draw arrows to match these up. We're going to place bonding electrons. So I'm going to redraw this just for you guys. You guys don't have to redraw it when you're doing it on your own. I just want you to not be confused with what I'm doing. It says, okay, place bonding electrons in pairs to connect the atoms. 2, 4, 6, and 8. Put the rest of the electrons on the outsides in pairs following the octet rule. Well, octet rule means an atom can hold 8 electrons. So we started with 32. We used up 8 electrons, right? So we have 8. I'm just going to start throwing them on. Doesn't matter where. You just distribute them evenly around every other atom. Okay. Carbon wants 8. Does it have 8? 1, 2, 3, 4, 5, 6, 7, 8. Yes, it has 8. So we can't add any more electrons to carbon. We can add them to chlorine. So I'm going to start with 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. All right. So it says, oops. Sorry, let me rewrite that. I just want to do it in order. So let me just, because you guys are using this as reference, let me make another one that we're going to add those electrons to. All right. So again, that's carbon. These are chlorines, C and L. All right, so then we start putting them on, right? So it's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. All right. So now let's check if it satisfied the octet rule. So carbon has its 8 electrons. Cool. Carbon's quote unquote happy. Let's look at all the chlorines. This chlorine has 8 electrons. This chlorine has 8 electrons. This bottom chlorine has 8 electrons. And this left chlorine has 8 electrons. And we are good. All have 8 electrons. So this is the Lewis structure. Carbon in the middle. And you don't have to, again, draw the circles. I'm just doing that to show you guys. So this is going to be the actual Lewis structure. Each of these chlorines will have 8 electrons around them. Carbon has 8 electrons around it. All right, so this is the answer to, if I asked you to draw a Lewis structure of CCl4, that would be it. All right, the next one is CH2O, right? Out of CH2O, so let's do that here. We have carbon, 2 hydrogens, and an oxygen. So carbon has 4 valence electrons. Hydrogen has 1. Again, that's from the periodic table. We have 12 valence electrons for CH2O. Okay. Now, let's draw the skeletal structure with these tips. Hydrogen, fluorine, chlorine, bromine, iodine on the outside. It has to be symmetrical. Typically, carbon's in the center. Let's throw carbon in the center. But we know the hydrogens have to be on the outside. And we need to put an oxygen there. Symmetrical, right? If you draw a line down the C and O, they're mirror images. All right. Next step, draw or place bonding electrons in pairs. So bonding electrons. And let me point these out. These are bonding electrons. These on the outside, those are what are called lone pair of electrons. They are non-bonding because they do not participate in forming that bond. These inside ones form are the connections between those two atoms or those atoms, right? All right. So let's see. This is step 1, 2, 3, 4, 5, right? So now we're on step 3. Place bonding electrons in pairs. 1, 2, 3, 4, 5, 6. All right. Next step. Place the rest of the electrons outside in pairs following the octet rule. Well, hydrogen follows the duet rule. It can only hold 2 electrons because it's on the first row of the periodic table. So now we're going to throw electrons on the rest of the molecule, and we can only add it to the carbon and the oxygen. All right, so I'm going to start with the oxygen. 1, 2. Back to the carbon, 3, 4, 5, 6, 7, 8. All right, let's see, check it out. Hydrogen has 2 electrons because it's sharing with carbon. This hydrogen has 2. This carbon has 8, which is perfect. And this 1, 2, 4, 6, 8, 10, 12. Oh, sorry, I miscounted. Let me do that over again. All right, so let's do that. So oxygen. So we have 6, 7, 8, 9, 10, 11, 12. Well, hydrogen has its 2. This hydrogen has its 2. This carbon has its 8. Uh-oh. This oxygen only has 6, which we need more, right? Oxygen needs its octet. It wants 8. So what do we do on step 4 if an atom doesn't have all its electrons? Well, it's going to borrow from its neighbor. Okay, so I'm just going to draw this like that. That's the same, right? We still have those 6 electrons around oxygen, but its only neighbor is carbon. So carbon is going to come and share its electrons with oxygen. So it's going to look like this now. Carbon, hydrogen, hydrogen. Now we have 2 sets of electrons. Let me make that a little bigger. So I have a little bit more space here. All right. 1, 2, 3, 4, oxygen. 1, 2, 3, 4. Now I'm going to draw those circles just to show you where those electrons are. Hydrogen. has the two electrons. This right hydrogen has two electrons. Now check out this carbon. This carbon has now 8 electrons. And the oxygen also has 8 electrons. So now everything was quote unquote happy. So this is the Lewis structure of CH2O. Now, one thing I want to point out is there's other common things, right? Carbon has 4 bonds. One, two, and this is a double bond because it shares 2 pairs of electrons. So let me write that. Double bond because shares 2 pairs of electrons. All right. Oxygen now has 2 bonds, which we have the double bond, and 2 lone pairs, right? So those are common things, but they usually happen, but not all the time. So this is the Lewis structure for CH2O. We used up all the electrons. Everything has a bond between it. The hydrogens have 2. The carbon and oxygen both are happy with their octet of electrons. All right. All right, we're just gonna do more and more examples of this so we get good at this stuff. All right, let's do CO, carbon and oxygen. Carbon has 4 electrons, oxygen has 6. We have 10 electrons total. You can only draw this one way, C and O. They're connected, right? Because it's a molecule, right? So here we have 1 electron, 2 electrons. Oops. So I'm gonna go in order. You don't have to do an order my way. I'm just doing it because I want y'all to see this, right? The 2 electrons there. So we started with 10 electrons. We used up 2. We have 8 electrons left to go, and we just put them on everything. 1, 2, 3, 4, 5, 6, 7, 8. Well, carbon does not have 8 electrons. Oxygen does not have 8 electrons. So carbon is not happy. It shares with oxygen. If oxygen isn't happy, it shares with carbon. So both those electrons go in the center, and it looks something like this. Now I'll show you. This carbon has 8 electrons. That oxygen now has 8 electrons. So since they both are satisfied with the octet, that's now the Lewis structure, and that's the Lewis structure, right? And that here is a triple bond because it shares 3 pairs of electrons. All right, let's do CO2, C-O-O, because that 2 means there's 2 oxygens. So 4, 6, and 6, we have 16 electrons total. The only way to draw this symmetrically is C, O, and O. We'll put the bonding electrons in first. 1, 2, 3, 4. Next, we're going to put the rest of the electrons. We used up 4, but we have 12 left. So 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Well, this oxygen is not happy. It only has 6. This oxygen is not happy. It only has 6. This carbon is happy because it has 8. So what we need to do is, since the oxygens are not happy with their 6 electrons, they have to share with the carbon. All right, so then it looks like this. Carbon with now a double bond to each of the oxygens. Oxygen has 8, Carbon has 8, the other oxygen has 8. So these are double bonds. All right, we'll do more practice problems. All right, CO3 2 minus. So we have carbon, we have 3 oxygens because it's the 3, O, 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 and then we have this 2 minus. I'm going to put in parentheses, right? If it's negative, that means it picked up 2 electrons, right? So it's going to be 4, 6, 6, 6, and 2. That's 24 electrons total. Draw the skeletal structure with these tips, right? Symmetrical, so the only way you can draw it is kind of like that. Place bonding electrons in pairs. 1, 2, 3, 4, 5, 6. All right. And let's start throwing them on everything. 6. Sorry. I'm going to draw a little, just a line to keep them separated here. 1, 2, 3, 4, 5, 6. All right, the rest of them 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. It doesn't matter. Now we can go to the right or down, and you can just pick one. 24. All right. This left oxygen is happy. It has 8 electrons. The carbon is happy. It has 8 electrons. The bottom oxygen is happy. It has 8 electrons. The right oxygen is not happy because it only has 6 electrons. So what's going to happen is, since it's not happy, it's going to borrow from its neighbor. Share with its neighbor, right? So it's going to be now carbon. Remember, when in doubt, follow these rules. And they should get you to the finish line. It won't solve 100% of all molecules across the universe, but it will solve almost all of them in our class and future chemistry classes, right? So here, everything has an octet, and this here is a double bond. Now, don't go out of order. Go down the list. Do step 1, do step 2, do step 3, do step 4, check step 5, right? Do not go out of order because it's going to throw you off, right? All right, so let's do this one now. Nitrogen, we have 4 hydrogens because of that 4. The 1 plus, we have to put, let's just put that here in parentheses. So if you have a positive charge, that means you're actually going to subtract 1. Nitrogen has 5, 1, 2, 3, minus 1. Oh, sorry, 1, 2, 3, 4. So 5, 6, 7, 8, 9 minus 1, we have 8 electrons total. Only way to draw this symmetrically is that I know of, right? Hydrogens have to be on the outside. And let's start making these bonds. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8. Well, we have no more electrons to use. So let's check. This hydrogen, is that hydrogen happy? Boop. Yep. This hydrogen happy? Yep. This hydrogen? Yep. This hydrogen? Yep. What about this nitrogen? Yep. It has 8. So it's going to look like this. Just like we drew, but we could leave out those circles now. 1, 2, 3, 4, 5, 6, 7, 8. Since this is an ion, we're going to put this in brackets, and we're going to say 1 plus. I forgot to do that here. We're going to put this in brackets. This is called the carbonate ion, and this is going to be 2 minus. All right. So again, go down the list. If there's something you don't understand, clarify it, keep going. All right, let's do these now. These are pretty common molecules, especially in chemistry. H, H. Oh, this is water, H2O, 1, 1, and 6. We have 8 electrons total. Now, draw it symmetrically. H has to be in the outside. We're going to place the bonding electrons first. 1, 2, 3, 4. And then now everything else. But hydrogen can't hold anymore, so we can only put them on the oxygen. And again, these are the lone pairs. These are the bonding pairs of electrons. Sorry, lone pairs of electrons, bonding pair of electrons. And if you look at oxygen, 2 bonds, 2 lone pairs, we're good to go. All right, let's do NH3, NH. 5 valence electrons, 1, 1, and 1. We have 8 electrons total. The only way I know how to draw this symmetrically is N, H, H, and H. We're going to put the electrons in, bonding electrons, 2, 3, 4, 5, 6. And then we have to put all the other electrons, which are only 2. So 1, 2, 3, 4, 5, 6. We have to use up 2. Hydrogen can't hold anymore, so we put it on the nitrogen. Happy, 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 and happy. So we don't do anything else. And if you look at the suggested bonds, right, it says nitrogen wants 3 bonds and 1 lone pair. We have 3 bonds to hydrogen and 1 lone pair. So this is the Lewis structure. This is the Lewis structure of this. Again, these are covalent bonds. So again, write down these tips or use the book's way, or again, use YouTube, Google, whatever you want, but you want to make sure you know how to do these and you understand these. All right, let's check some ionic and molecular compound stuff. Again, ionic is metal plus non-metal. Covalent are 2 non-metals. So I'm going to underline anything that's a metal. Sulfur, O2, there's no metal. So this is covalent. All right. Calcium is a metal, so it's ionic. Calcium is metal. Nitrogen and hydrogen are not metals, so no metal. That's covalent. There, aluminum is metal, so this is ionic. All right. Well, I think that wraps it up here. So thank you for tuning in to another video of Chem with Com, and I will catch you next time. Thank you very much. Sorry, I forgot to do the word of the day. The word of this video is Houdini. Houdini. So the word of the day is Houdini. All right. Well, thank you very much.